Hello guys, welcome back to the channel. So today we are going to learn about merge sort. So first of all, most of the people will be having a fear when coming to merge sort. So first you need to know why only merge sort. See, merge sort is an algorithm where we use divide and conquer strategy. What are we using here? It is also known for most of the people here. That particular thing is called as divide and conquer. So what do we do here is, in this divide and conquer, for suppose we have a single problem. We will try to divide that particular problem into multiple subproblems recursively again and again. Again, this is being divided. Again, this will be divided. In the similar way, again here also there occurs a division. Here also there occurs a division until some base case. Once that particular case is successfully solved, then we start merging them back one after the other, and finally we get a feasible solution. Feasible solution. This feasible solutions, there are a set of feasible solutions. In those, what is the best solution? We call that particular solution as optimal solution. Optimal solution. Now, what are we going to do is we have this divide and conquer approach. So, why we need to use merge sort? We have insertion sort, we have bubble sort, we have selection sort, we have many other sorting techniques. But why only bubble sort every time? Sorry, why only merge sort? Because merge sort has some complexity relaxations or complexity leniences. So that is the advantage that we have with the merge sort. If you observe carefully, in merge sort, what do we have is, just wait a minute. Mm, come on, come on, come on. Yes. So in the merge sort, what do we have is, we used to use this divide and conquer approach in order to solve the solution. But basically using this divide and conquer will give optimal solution. We have insertion sort, bubble sort, selection sort, but they have time complexities which are larger than the merge sort algorithm. So that's why we use merge sort. And another way, in insertion sort or selection sort, or we have another sort called as count sort, or we have another sorting technique called as bubble sort. What do we do here? The time complexity increases in the worst case, like big O of n square, and sometimes mostly insertion sort has a normal time complexity of big O of n square. So that is even not a worst case of merge sort. So merge sort algorithm is something which is that much efficient when compared to insertion sort or bubble sort or any other sorting techniques. Similarly, we have another twin brother of this merge sort called as quick sort that will be coming in the next sessions. So there I will cover him. Now we are going for the first brother merge sort. First of all, I like to explain how these arrays are taken. So if you observe, this particular array is sorted and this array is also sorted. So merge sort basically considers two sorted arrays while performing its algorithm. So what do we do is, as I have told earlier in the divide and conquer strategy, we divide this into two different halves. One half, the second half, and here we take another half. Again we delete, I mean like we divide it, and we will try to perform some kind of operations. in order to provide a huge final array that is possible after doing these operations. So that final array can be given only through performing optimal algorithm. So that is what merge sort algorithm. So now the first thing what I do is we will write a predicted answer. What could be the answer? First of all, in order to get a conclusion, we want to get a clarity, we need to write an expected solution. What could be the expected solution? So I will write the expected solution here. The solution could be -4, comma 4, comma 5, comma 6, comma we have 8, then we have 9, we have 10, we have 12, we have again another 12 and 19 and 21. So this particular thing is the final possible answer that we get after the algorithm completion. So now this is sorted array, right? So both are sorted arrays. For what we are using merge sort? In order to merge two sorted arrays. So now what do I do is, initially, if we go for the combining approach, like directly we sort, so we go with each and every value in the particular array. So we have n sized array plus m sized array. So n plus m should be the size of new array that is being formed. And all these n plus m elements will be traversed from here to here, like, oh, sorry, just wait a minute. From the first element to the last element, all these particular elements are traversed one by one. So that's why we get a time complexity of big O of n plus m in this approach. This is one kind of approach where we get big O of n plus m. So how do we get big O of n plus m? So not only big O of n plus m, there is still some approach that we still extra complexity we have. So the first thing is big O of n plus m is for combining these particular arrays at last. This is for combining. Plus, what do we have in addition? If we perform bubble sort or insertion sort or selection sort, we used to get again a big O of n whole square for a single array. But here, two arrays with two different sizes. So we have n plus m as the new array. So we get two for loops for this process, or both three of the algorithms. We used to have these kind of two for loops in them. So we get n square times. So we have n plus m as the size, n plus m whole square. Then finally, combining the first, that is sorting, as well as, I mean, like, combining the first one, which is called as combining. This is combining. For the combining, we are taking big O of n plus m complexity. And for sorting, we take big O of n plus m whole square complexity. So big O of n plus m plus big O of n plus m whole square. So if you consider this as x, and if you consider this as x square. So what is greater term? X square is the greater term. So what will be the answer? Big O of n plus m whole square. So this is the answer that we get. This is the answer that we get. So if you understand the first approach, just take 1 minute to just pause the video and understand what did we do, how are we doing. Okay, the first approach is nothing but we will take a random array. Initially, I didn't like నేను అరే తీసుకోలేదు. మీరు ఇమాజినేషన్‌లో ములుగుతారేమో అని. మీరు ఇమాజినేషన్ చేసుకోకపోతే ఐ కాంట్ డూ ఎనీథింగ్. ఐ విల్ ట్రై టు ఆహ్, లైక్ నేను తీసుకొస్తాను ఆ అరేని. వెయిట్ ఎ మినిట్. మై గాడ్! ఇట్ ఈస్ టేకింగ్ సమ్ టైమ్. సో, ఎనీవేస్ ఎలా కాదనుకున్నా, ఎంత కాదనుకున్నా వి హావ్ అవర్ ప్రాబ్లమ్స్. సో, ఇప్పుడు we can take an array C of n plus m, and in that particular C of n plus m, we can have the collection of all of these elements. అంటే C of n plus m is nothing but this particular set of elements from here to here like that. So, if you understand, just pause the video and try to think what we are doing and what we had done so far. Okay, guys. So now we are going with the second approach. So here, what are we going to do is we used to follow another kind of sortings. So 1 minute, మనం కొంచెం ఎడిట్ చేద్దాము. This particular thing is A1, that is approach 1. సో కొంచెం జాగ్రత్తగా గుర్తుంచుకోండి. ఓకే. అండ్ డివైడ్ అండ్ కాంకర్ క్లారిటీ వచ్చింది కదా, వాట్ ఆర్ వి డూయింగ్, హౌ డిడ్ వి గెట్ దట్ అనేది. సో దట్ ఈస్ సెట్ ఆఫ్ థింగ్, దట్ ఈస్ వన్ సార్ట్ ఆఫ్ థింగ్. ఇప్పుడు నౌ వీఆర్ గోయింగ్ ద సెకండ్ అప్రోచ్. ఫస్ట్ అప్రోచ్ ఇది. వీ విల్ ట్రై టు ఫస్ట్ ఆఫ్ ఆల్ కంబైన్ ది ఎలిమెంట్స్ డైరెక్ట్లీ. అంటే మనం వాట్ ఆర్ వి డూయింగ్ ఇన్ ద ఫస్ట్ అప్రోచ్ ఇస్ we will take these elements directly, guys. And -4, sorry, it is 6, 12, 19, 21, and these elements as rest 4, 5, 8, 9, 10, and 12. So we will take these elements one after the other. Just we combine these thing into a single array, and then we perform bubble sort or insertion sort or selection sort, and then we get this particular time complexity as we have n plus m size. And for combining, we have n plus m. This size is n, and this size is m. So n plus m, that is we go of n plus m for combining the arrays, and we go of n plus m whole square for performing the sorting operations. So in combination of these two complexities, the overall time complexity for this particular thing is big O of n plus m whole square. సో ఇది మీకు కొంచెం సింపుల్గా చెప్పాలి అంటే ఇదే. దిస్ ఈస్ ద ప్రాసెస్ దట్ ఐ ఫాలో. మీకు ఇంకా అర్థం కాకపోతే డోంట్ హెజిటేట్, యూ కెన్ ఆస్క్ ఇన్ ద కామెంట్ సెక్షన్. ఎస్. ఓకే, డన్. మరి అంత అక్కర్లేదు. యా. నౌ వీఆర్ గోయింగ్ విత్ ద సెకండ్ అప్రోచ్. దిస్ అప్రోచ్ is oh my god, this approach, this approach is A2. Second approach. What is the second approach in the sense? What are we going to do is we try to optimize. అంటే we have an, the array, and bm, another array. So what do we do now? We have this array, right? So keep this aside, and we have this particular array here, and keep this side. So now basically what is our motto or approach or whatever it is, we will try to take directly all the n elements into C. So C of n plus m, that is obviously correct. But what do we do here is we will take first all the n elements of the array. means all these elements will be taken to here, this particular situation place. So డాట్స్ ఉన్నాయంటే ఎలిమెంట్స్ ఉన్నట్టు. జస్ట్ ఇమాజిన్ దట్ వీ హ్యావ్ సమ్ డాట్స్. ఎన్నున్నాయి? 4 + 4 8. సో 4 4 8. And here there are 4 3 7. So 1 2 3 4 5 and 6 7. So we have 8 elements here. So దీని size ఎంత? n. This is the size. And what is this particular size? That is m. So overall, what is the size? N plus M. Okay. So, excuse me. So, ఇప్పుడు మనం ఏం చేస్తున్నాం అంటే ఫస్ట్ వీఆర్ కాపీయింగ్ దిస్ n ఎలిమెంట్స్ డైరెక్ట్లీ ఇంటూ దిస్ పర్టికులర్ సి అరే సి ఏ నుంచి సికి కాపీ చేస్తున్నాం. సో వాట్ ఈస్ ద టైమ్ కాంప్లెక్సిటీ ఫర్ కాపీయింగ్ n ఎలిమెంట్స్? ఎవ్రీ ఎలిమెంట్ ఈస్ బీయింగ్ ట్రావెల్డ్, సో we go of n plus we will try to insert this particular element if it is like, for suppose ఇందాక ఎగ్జాంపుల్ లాగా 4 -6 and 4 అనుకుందాం. let us think like that. Now ఇది -4 6 and this is 4, right? So ఇప్పుడు if we place all these elements here, now -4 and 6 exist here. Now this approach tells if we directly take this particular element to this particular place and paste here, what happens? This is the approach. Now for this, what do we follow? Insertion sort technique. Insertion sort technique we follow. Insertion step is the name of this procedure. So insertion step we perform and we directly place. So then the array becomes like, as I have taken only 3 elements, -4, 4, 6. This is the final array if I consider only 3 elements. So for all the n plus m elements or n plus m positions, the n elements from the first array and m elements from the second array will be placed directly. So first we will fill n elements directly into this particular array. And next we will try to fill the mth element or first element of the m array directly into its desired position. This is the second approach where we have comparisons of insertion steps. So m elements are compared in the worst case n times. So we go of m into n. So what is this? Copying A to C. And what is this? This is directly we can write this process as insertion step. This is insertion step. Plus, if we insert, these have to move right from this particular place to so on up to here. They have to move, right? So if they didn't move means it is a blunder. Okay. So they have to move. So what do we do is we will print the array, right? So directly we will place, they will move because m into n will happen. But later we have to print this entire array like this. So it takes big O of n plus m again. So for printing again it takes big O of n plus m. So finally this is the time complexity. If you compare with the previous approach, big O of n plus m into big O of n plus m whole square, it is big O of n plus m whole square. Here, if you see in this particular approach, if we consider this as x, sorry, better not to consider, again we get confused. So what is the maximum value, like n or m into n or m plus n? What is the maximum value? M into n. So now the complexity becomes big O of m into n. So we can have this particular thing like maximum of like this. Nothing happens. This is second approach where we directly place. So now I'll show you the tracing. How does this process happen? So we have -4 here. Yeah, wait, -4, and we have 6. We have 12. We have another 19. Oh, sorry. We have 19 over there and 21 and another 21. So from B array, we are getting 4, right? So what do? We directly want to place here. We directly want I mean, this particular 4 to be placed here. So what do? First of all, we move these elements one by one to this particular position. So what happens? Now the 6 will be cancelled. Now 4 will be placed automatically. Now here it becomes 6. Here it becomes 12. Here it becomes 19. Here it becomes 21. And finally, then this particular 21 will come to here and it becomes 21 here. So this is the process what we are trying to do. So you might be asking, bro, what is the space complexity of the previous one? You are told the time complexity. Then what is the space complexity? So yeah, the space complexity is basically the amount of comparisons happened. So n elements plus m elements. So n plus m elements compared. So big O of n plus m is the space complexity. And again here also, you may ask, Anna, what is the space complexity? Yeah, space complexity is here again big O of n plus m. See, our first and most foremost preference is for time complexity only, not space complexity. But even space matters, but mostly the highest importance is given for time because once time is completed, it can never come back. So that is the reason. So here the elements which are already inserted are not moved or disturbed. Like for suppose now 4 is successfully placed. If we have another 5, we will not touch 4. Okay. If we have 5, we already have 5 actually. So if we have to place here, we can directly place. Means 6 will be affected, 12, 19, 21. But 4, but 4 will not be affected because it is already sorted successfully. Okay. So that is one thing that happens. And now the most optimized approach we have, that is approach 3, that is two pointer approach. What is that? Two pointer approach. So in this particular two pointer approach, what do we do is, in this two pointer approach, this is mostly also known as epic solution for merge sort. So these, I mean, like approach 1 and 2 are kind of approaches that we can follow, but this particular two-pointer approach is most preferred. For this particular approach only, we get the time complexity of n log n. Okay, so I will tell you what happens now. So initially, we have an array n and another array bm. So we have this particular array and we have this particular array over here. So we have elements. What are the elements? -4, 6, 12, 19, 21. ఒకటి ఎక్కువ అయింది షికావత్ సార్ ఫీల్ అవుతాడు -4, 6, 19, ఇది 21. ఏంది మధ్యలో బూత్ ఏదో రాసాం మనం 12. ఈ ఎలిమెంట్స్ ఏంటి 4, 5, 8, 9, 10, 12. This is 12 and this is 4, 5, 8, 9, 10, 12. So we can remove this particular value. సో మనం కొంచెం ఎరేస్ చేయొచ్చు బట్ ఓకే మనం ఇలా పెడదాం సరిపోయింది. సో ఇట్ లుక్స్ గుడ్ అండ్ ఓ మై గాడ్ ఎటో పోతుంది. డన్. అంతే మనం అలా మ్యాజికల్ చేస్తాం కొన్ని. ఎక్కువ మాట దీన్ని కూడా కుదిస్తా. ఇంకా దీన్ని పర్ఫెక్ట్. Now this is the epic solution we have. What is meant by epic solution here is, guys, we have whichever the smaller, అంటే we will place 2 pointers, guys. This is P1 and this is P2. Minimum P1 and P2 is considered. Minimum of P1 and P2. Minimum of P1 and P2 is considered. Why minimum? Directly, if the minimum value is acquired, we can place it. So -4 will be placed. So we will take the array Cn plus m and we will try to add the elements now. So there also exists an element to keep the track of the count in the C array. So it is let it be some k. Let it be some k. So this particular P1 and P2 are in the 0th indices of arrays An and Bm. Okay. So now we used to have 2 pointers for both the arrays. Both are being compared. The minimum among them is taken and added into the C array. Once the element is placed, we do not compare it again. So once this particular 4 -4 is placed, in the upcoming comparisons, we will never have -4 again. Okay. So now, as this was placed, move. So P1 comes to here. So strike this P1 and P1 comes here. Now, minimum of 6 and 4. What is the minimum? 4. So place it. Now, P2 lo, I mean like P2 element is placed. The array which consists an int like a pointer P2, that particular array's element was placed successfully. So we just increment P2. Now, in P2 and this P1, this was not placed still. What is the minimum value? 5. So we will take 5. Now, this particular P2 will be again increased. Now, in this particular value and P1, 6. Minimum value is 6. So, 6 is placed and P1 is striked off and P1 comes to here. Now, it is 12 and this is 8. Minimum value is 8. So, P2 is striked off and P2 comes here. So, we place 8 here. Then the 9 comes. Even 9 is less than 12. So, again P2 gets incremented. So, we are at 10. And again P2 gets incremented, so we are at 12. So finally we are at 12. So again P2 element 12 is placed and now P2 gets incremented and comes out. Now I'll tell you. Wait for a while. Now I'll tell you. Now there are no elements left over. So this 12 can be placed first. Means like this 12 can also be placed first. This 12 can also be placed first. But it depends on the pointer which is moving forward. So, now what are we going to do is, the rest of the elements which are left over will be added directly. So, 12, 19, 21. Now the particular, like simultaneously the k value will also be moving, and yeah, even this happens. I forgot to do this, but anyways, k one after the other moves simultaneously with these two pointers, but yes, it has its own thing. So finally, this is the sorted array. So we take a variable k for tracking, and whenever we add elements, we increment k. So that is what I had done. So as I forgot to do that, I directly did everything in the last minute. Now, whatever the leftover elements, like if you observe carefully, I will write one uh, note here. So please ensure that you stick it to your mind. What is the note is, చదివారు అనుకుంటున్నా. If you read it, you can understand. So this is the third approach. So what did we do? We have an array of size n and this array of size m. మనం మార్క్ చేసే బదులు I can add here n and here it is m. So we know that we used a two-pointer approach. So in this approach, what happened? First, we slowly sequentially we compare the minimum elements of each and every index. So zeroth index, first index, second index, third index, fourth index. 0, 1, 2, 3, 4, and 5. So all the indices are compared one after other in order to get this minimum value. Once the minimum value was acquired, that particular minimum value is placed in this particular new array that we considered in the initial stage. So that is the two-pointer approach. So there is an edge case in this. What is meant by an edge case? If you observe, 12 and 12 are placed. What are the leftover elements? 19 and 21. So this particular thing can be called as an edge case, as this particular thing is at the edge. So what do we have? We have this particular solution like this. So here you may ask, Anna, what is the time complexity here? I'll tell you. Ultimately, you know the time complexity. What we have, that is, we take the minimum element. So once the element is fixed, it will not be compared again. It won't be compared again and again. So n elements are existing. and log n times. And obviously the space complexity, that is we go n in worst case, and we go of 1 in best case. So this is worst case WC and this is best case. So ante, all the codes and all the kind of approaches will be explained in the next video. So make sure that you subscribe to the channel and ensure that you will definitely learn something. సో కోడ్ డిస్కషన్స్ అవన్నీ జరగాలి, మీకు అర్థం కావాలి అంటే మన డిస్కార్డ్ సర్వర్లోకి జాయిన్ అవ్వండి. కోడ్ డిస్కషన్స్ ఛానల్ ఉంటుంది అందులో. ఆ సర్వర్లో ఆ ఛానల్లో మీరు డిస్కషన్ మీరు స్టార్ట్ చేస్తే ఆటోమేటికల్లీ ద పీపుల్ హూ ఆర్ ఇంట్రెస్టెడ్, who are wanting to code, who are willing to answer your questions, they will start answering them. So that's it, guys. Thanks for watching. And the all time complexity explanations and the code explanations will be given in the part 2 video. ఇది part 1 మాత్రమే, part 2 ఒకటి ఉంది మళ్ళీ. సో అందులో ఇద్దాము. సో until then, thank you. Bye bye.
Oh, 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 oh.